3.5, using properties of parallel lines. As you notice, chapter 3 is all about proving stuff. Chapter 4, we're going to get into triangles, and we're going to have a lot more proofs. After that, it'll start calming down, so I know you guys aren't liking it. Stick with it. Learn the theorems, learn the definitions, and you'll be all right. First theorem, 3.11, if two lines are parallel to the same line, so if this line is parallel to this line, and this red line is parallel to this line, so both of these lines are parallel to the same line, well, it makes sense that they're going to be parallel to each other. We'll see a proof of that in a bit. Theorem 3.12 says in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So this line is perpendicular to that one. This line's perpendicular to that one. Therefore, these lines are parallel to each other. So here's a little proof of that last theorem, or theorem 3.11, not the last one, but the first one where we have three parallel lines. So in the proof, it says we had R parallel to S, and we have T parallel to S. So we want to show that R and T are parallel. It seems like it'd just go by the transitive property, but we don't have transitive property of parallel lines. We have that for congruence and equality, but what we're going to have to do here, I'm going to start with my given, and I'm actually going to do a flow proof. You wouldn't have to do it. It just says prove it. You get to choose how you want to prove it. That's one given. And from that given, what do I know? What can I conclude? What can I draw? So I look, if R is parallel to S, I know angle 1 and angle 2 have to be congruent. Okay, angle 1 and angle 2 are alternate interior angles. So alternate interior angles theorem says that those angles have to be congruent. Remember, the converse shows that the lines are parallel. So I know angle 1 is congruent to angle 2. I look at this and I also say I know angle 2 is congruent to angle 4. This has to be congruent to that. So since angle 2 is congruent to angle 4, that is the, what kind of angles are those? Vertical. So notice that's standing alone. It didn't come from anything else. But now that I have that piece of information, these two things, if angle 1 is congruent to 2 and 2 is congruent to 4, I know angle 1 is congruent to angle 4. And that is by the transitive property. Okay. And I look at this, I haven't used the second piece of information yet, the second given. And I'm just going to double check if I use my second given. I'm just mentally thinking what I want to get out of it. I want to show that if S is parallel to T, that I can conclude that angle 4 is congruent to angle 3. And why is that? Why is angle 4 congruent to angle 3? Those, what type of angles are 4 and 3? Corresponding. Corresponding angles. If you put theorem, I wouldn't count it wrong on a test, but it is the postulate. Yeah. Terrible spelling, I apologize. And now, using these, I can show that angle 1 is congruent to angle 3. Transitive property. Skipping over angle 4 there. Now if we go back to the picture, we want to show that R is parallel to T. We know, so R and T, we know 1 and 3 are congruent. When we have congruent lines, we can say lines are parallel. R and T it was, right? You see the picture, it makes me a little nervous. Yep, so what we're trying to prove, R and T are parallel. And the reason for there, those were those corresponding angles. But is it a postulate or was it the converse? And remember, you use the converse to show lines are parallel. So corresponding angles converse proves that theorem. Okay. Now you could have done it in a 2-column proof, it would have been fine. Here, this question, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately above it. Explain why the top stripe is parallel to the bottom stripe. So we're given that this red stripe is parallel to the one immediately above it, white. And the white stripe is parallel to this one. But that doesn't show that this red stripe is parallel to the red stripe until we use theorem 3.11. So here's where having in your notes the theorems written down helps, because you can just name that theorem. If you didn't, you'd have to write out the whole theorem, and that takes a lot of time. So that's why we name these theorems. So using theorem 3.11, I can show this one's parallel to this, and then I could show this red stripe is parallel to this white one, and I could continue that logic. Therefore, the bottom stripe is congruent to this one by theorem 3.11 again, until we work our way all the way to the top. Okay? In a proof, you have to be very specific, even if it is obvious. You can't just assume that someone's going to take your word for it. And this last proof, you are constructing a garden. The diagonals plantings make 25-degree angles and 65-degree angles at each corner. Prove that the opposite sides of the garden are parallel. So we want to show that opposite sides, this side and this side, are parallel, and this side and this side are parallel. Okay, to do that, we're going to start with our givens, that we're given some angle measures. So we could say we're given that angle 1 is 65 degrees, angle 2 is 25, angle 7 is 25, and angle 8 is 65. Those were given to us. And now what I can also conclude, angle 1 plus angle 2 is the total angle, BAD, and angle 7 plus angle 8, these two angles add together to be angle ADC. That's the angle addition postulate, when two angles add up to the bigger angle. Okay, so we're going to draw all these things together. This side, we're going to substitute angle 1 in for angle 1, or 65 in for angle 1, 25 in for angle 2. That's going to equal BAD. So we get BAD equals 90 degrees. We added those together at the same time. We simplified it. You don't need to write simplify in there. You can just skip to it. Same thing there. Substituted those in here, simplified it, and got that those angles are right angles. And now in two angles, okay, so we showed that these angles are right angles, so they are, we can say that they're perpendicular. They're perpendicular, two lines perpendicular the same. They're going to be, so the reason why they're perpendicular is definition of perpendicular, which says they form a right angle, right? And once we say they're perpendicular, we can use that theorem 3.12 that says that those lines must then be parallel to each other. So that proves that BA is congruent to CD, and you could continue that proof for the other two sides. There's your homework. Let's work on it tomorrow in class. If you got any questions on those proofs, feel free to ask them. I hope this stuff's making sense, but it just takes practice. Have a good night.